Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hi, my name is Dr. Jonathan Spring. I'm a senior vulnerability researcher here at the Software Engineering Institute CERT Division. I'm joined today by two of my colleagues, Dr. April Galyardt and Angela Horneman. We're going to be talking about machine learning in cybersecurity, specifically 7 questions for managers and decision makers. Welcome, April and Angela.
Hi.
Let's start off by telling the audience a little bit about what we do here at the SEI.
I can talk about what I do.
Yeah, go ahead.
So I am a machine learning research scientist, and I work with the Tactical and AI-enabled technologies group.
I'm Angela Horneman. I work on the situational awareness analysis team. I'm the team lead. We do a lot of work helping people understand their area of an organization in cyberspace and making sense of it to make better decisions.
Great, thanks. And I work on the vulnerability analysis and threat team. So we do a lot of things around vulnerability analysis, vulnerability management, coordination, and sort of keeping an eye on the threat space and what is and is not really a big problem. So before we delve into the topic of machine learning, can we define for our audience what we mean by AI and ML?
There's actually, this is not a trivial question. There's a lot of different definitions out there. One of the key AI textbooks has like 8 different definitions in there. But the one the Department of Defense has adopted is AI is a technology that can do a task automatically that would normally require human intelligence, such as translating a document. And the machine learning also has several different definitions, but machine learning is extracting information from large data sets, often to power an AI.
Great. Thanks, April. So, Angela, can you tell us a little bit about the role that machine learning has to play in cybersecurity? Like, what's the state of the practice?
So there's a lot of using it to try to make sense of large data sets, because a lot of machine learning specifically is building information and models from large data sets. Cybersecurity has huge data sets. The idea is to try to use that to automate or to make better some of the processes that are currently going, whether it is incident response, malware detection, threat detection. Currently, it is used well with some of the malware detection. A lot of the areas where it is trying to be used, for instance, in incident response, it's a lot more iffy. It takes a lot of dedication, a lot of tuning, a lot of keeping up to date to get some limited utility from the solutions that are being put in place. A lot of organizations don't have the resources and capability to effectively use it.
Great. Anything you want to add, April?
Well, in some of the ways that Angela just mentioned, in cybersecurity, it's not too different than how it is, how machine learning is in a lot of other applications. Like, you have to stay on top of it because things change moment to moment. But there are a few things, and maybe we'll talk about them in a little bit, that do make machine learning in cybersecurity different than some other applications. Yeah,
so I think then let's talk about our technical report, right? So we co-authored this with Ed Stoner, Josh Fallon, and Lee Metcalf, and we outlined 7 questions, right, that managers and decision makers might want to ask. But can you maybe talk a little bit about what the types of questions those are, like what they help the managers and decision makers figure out and do?
Yeah, so we have a few questions that deal with identifying your goals and how you actually expect a machine learning or AI system to accomplish those goals. There's a few questions about how do you actually secure these systems. If we're talking about cybersecurity, securing these systems is part of cybersecurity itself. And then how do you actually evaluate what is happening with the tools? Are they really meeting those goals that you have? And all the other needs around some sort of solution.
So what are the ways that are different for a machine learning tool in cybersecurity for it to be protected than a machine learning tool in other areas?
So the to be protected there maybe throws me off a little bit, because when I'm thinking about one of the biggest differences between cybersecurity and other applications, it's that often in cybersecurity, the thing that you're looking for is a rare thing. And that in particular makes it different than, say, machine learning on autonomous vehicles, because there you want to identify cars and people, and there's lots of cars and there's lots of people around. Looking for rare things is a little bit different.
Angela, can you tell us a little bit about maybe contested environments and how that might be different?
So there's also in the cybersecurity realm a lot of, it's an adversarial environment. There's a lot of people trying to undo everything that you're trying to do. They want to deliberately deceive whatever systems you have. That doesn't go away when you have machine learning or an artificial intelligence solution. In some sense, it gets worse because you don't have people, machines aren't yet at the ability to be able to detect interventions. Humans still need to do that. Humans are bad at that, but machines are even worse. So using machines in these areas just compounds the issues. So if you're thinking about something like a phishing email, it's one area where machine learning is being put into good use. How do you detect some phishing, your email, your spam filters? The better you can make your email look like something legitimate, the less likely and the harder it is for any machine or an algorithm to detect the fact that it's phishing. So we have environments where people are deliberately trying to make their interactions, their behaviors, their instances look specifically like something that it's not. That doesn't happen in a lot of realms.
So can you also maybe then, because this is so difficult, can we talk a little bit about the importance of sort of understanding what the tool is doing and getting an explanation for what the tool is situated in your environment to do and how it interacts with the other tools that you have in your cybersecurity environment?
Yeah, so whether or not you can get an explanation at all and what kind of explanation you get, it depends highly on what tool you decide to use. And so that's actually one of the key things that you should consider when you're deciding what kind of solution you need, what your problem is. Because if you don't have ahead of time an idea of the explanation that you're going to need and that kind of explanation, you might not be able to get it out at all after you implement some sort of solution.
I think it goes back to the first few questions that we ask in the paper, which is, what actually are you trying to accomplish? Right. What do you need to know from your results? How is it going to fit into your larger context? These systems can't exist in isolation. A lot of cybersecurity is very context dependent. So having just one specific data source or one specific topic, you're not necessarily going to be able to answer the question. You need to be able to, for instance, about malware detection. You need to understand what actually can happen in your system, who things should be coming from, who they shouldn't be, what sort of programs you allow to run on your machines or not. If that context is not incorporated specifically into the solution, you have to be able to incorporate that somehow into a greater workflow. So that also impacts the interpretability you need of your results from your solution.
So I think maybe a couple of weeks ago you were saying that one other part of context is what the adversaries are doing now and how much that informs what the adversaries might be doing in the future or doesn't inform. Because as you were saying, we know the adversaries are going to try to fool us. Right. Can you talk a little bit about how time sensitive the training data then is too? Sure.
So cyberspace is a rapidly changing field. People change. They don't do the same thing all the time. We evolve our actions to respond in response to our environments and the results that we get. A lot of things may need trained continually. The people who do malware signatures for something like a virus scan, they are training their modules continually because they're constantly getting new examples of malware or phishing or whatever the case may be, bad websites. Those models are updated continuously. There's some things that could go a little longer if you can actually get a good data set to begin with, but because the area is so volatile.
Right. Well, kind of on the malware example and the taking context into account, there's a lot of malware tools out there in academic papers that are like, well, I trained my machine learning model to identify malware. And, well, they went to a giant malware repository and trained their model on that. And that's all the stuff that we can already find using the models and methods that we have. And so when you get high accuracy on that data set, that doesn't necessarily mean anything other than that you can recover the tools that already exist, and that you don't know what you didn't find. And
Right.
so that's an example of something you don't want because that's not your right training data.
That sounds like a similar problem to what we already have with evaluating blacklists, right? So it's already the case that it's really hard to say what new contribution some sort of detection mechanism has, because they all are sort of finding different things, and that's the intention. So does machine learning do anything to make that problem better or worse?
Scalable. I think one of the most compelling reasons to use machine learning is scalability. How do you deal with all the data that exists? You can't do that as a human. You can't do that with most of the existing non-ML algorithms. So the biggest draw for a lot of people for machine learning and artificial intelligence is being able to scale up to the size of what we're dealing with.
Right. I think that's exactly it. But what I was thinking was that you're asking, does it make it better or worse? And the answer is, well, it depends. If you're not incredibly careful, it can make it much worse. If you are careful, you can make it better and achieve that scalability.
So can you maybe tell us a little bit about how the questions that we suggest people ask reduce these risks to increase the scalability and let people do it a little bit more safely?
So one of the questions, how would you find and mitigate unintended outputs and effects? That's a big one, that anticipating, or at least trying to anticipate the unintended consequences. Kind of going back to the rare events, if you have a lot of rare events, your algorithm is very likely to detect a lot of things that are not, a lot of false positives. And so having something in place to deal with all those false positives, or training your model so that you can reduce that number of false positives, those are necessary things to make your system useful and scalable.
Yeah, I think also the first three questions: what's your topic of interest? What information will help you address the topic of interest? And how do you anticipate that an ML tool will address the topic of interest? Those are not surface questions. Those are actually looking for you to get down deep, to talk to both SMEs in the area where you're trying to solve the problem, as well as data science SMEs and software engineer SMEs. How can you actually build the system to make sure that you can not only address what you need to do, but get the correct output? And do you even have the resources you need to be able to tackle this?
So is there a strong sort of like data curation dependency on being able to successfully have a good machine learning deployment?
Definitely data curation, but even beyond data curation, even understanding, is the data that I have available or that I can get, does it contain the answer, or can I use it to create a model for the solution I need? That is still a huge question in a lot of the use cases where people want to apply machine learning for cybersecurity, specifically in the realm of general threat detection, not necessarily malware detection, but malicious traffic, something like an IDS. A lot of the data we have doesn't really include the information that you would need to make a determination, which in that case would be something like context.
Yeah.
What is actually supposed to happen? What are
policy,
your policies? Who should be doing what? Who should not be?
Right. Well, I think to even a simpler example of like if all you have is the amount of traffic that's going through the network, that can maybe tell you there's something anomalous, but that doesn't give you a whole lot of information on what is going on.
Yeah.
Maybe you just have a lot of customers at the moment.
Yeah. Most anomalies are not malicious. Most anomalies have nothing to do with security. They are just general ebbs and flows and new behaviors and explorations.
Right, but that's why I bring that example up, because if that's the only data you're looking at, then you're probably not looking at the right thing.
Right. So, changing gears a little bit, can you tell us a little bit about the sort of attacks specifically against machine learning tools to get them to intentionally misclassify events?
So it depends on what you have access to. If you have access and you can inject something into the training data.
You mean me as the attacker?
Yes, you as the attacker. If you are trying to attack
I
my
would never.
system, you would never. But let's suppose that you were.
Please.
You could try and attack my training data and inject things there or alter it in some way. You could try and attack my model itself and adjust some of the parameters in the model. You could try, if you don't have the ability to attack either the data directly or the model directly, if you look at what's coming out of my model and just look at that can maybe tell you where there are some holes. And so that's the kind of attack where you get in the self-driving cars, when you put stickers on stop signs, suddenly it looks like a speed limit sign, and the car does not stop and, in fact, speeds up. So you can make adversarial examples that will then make my model misbehave on those examples. So those are kind of the three big classes.
Yeah.
There's some variation
So
there.
within those classes, just to be clear, are those hypothetical examples or are those demonstrated attacks that have worked?
So there are many, many academic examples in each of those categories, and we are starting to maybe see some of them in the wild, out in the world.
So I think specifically for the one where you're attacking the training data, a lot of the methods currently used for building models, the training data is captured live, which isn't clean to begin with. So it's not a deliberate attack against the training data, but because it already includes some of the stuff you don't want or that you're detecting, you don't necessarily know it's in there to have labeled it correctly, or depending on, maybe you don't have labeled data, you just don't know it's in there. It is an indirect attack.
That seems like if you're learning based on your network traffic and the adversary can send you packets,
Yep.
that seems like that is a open vector. Is that right?
That is correct.
Yeah.
Yeah.
Okay.
So another way is not necessarily machine learning specific, but in the network traffic or IDS example, or even something like a phishing, if you just send enough traffic in general,
It looks like part of the normal.
something is going to get through because people can't deal with it. A lot of the output is still not auto handled.
Yeah.
Even when it is, some of it is going to be misclassified. If you send enough, you're guaranteed to get some sort of misclassification that gets through.
Well, and in the examples that you guys raised, there's one other thing that I wouldn't necessarily call it an adversarial attack, but there's feedback loops can cause their own problems. So even if nobody's actually attacking you, if I have an analyst who's looking at code and then their analysis of the code goes into my next training data, which then feeds back into the next thing they see, sometimes feedback loops like that can wind up in very strange places.
So is this sort of another, Angela, you mentioned earlier that there's it's rarely the case that anomalies are security events. Is this sort of feedback loop and ability for the adversary to change what's normal sort of another problem with treating weird things or anomalies or what's normal as what is security or what is secure?
Yeah. So humans are imperfect in what they do, just as the machines are. We also are very time constrained. We can't effectively go through everything that we're documenting. So sometimes we take shortcuts. We go through and say, oh, all these look the same. I'm going to close them all with the same resolution. If that is being fed into your feedback loop and it was not 100% correct, you've just shot yourself in the foot.
Great. So one thing that we do like to emphasize with the podcast series is transition. So if I am an audience member, no longer an attacker, but an audience member who is interested in using machine learning tools in cybersecurity, can you tell me where I should start, please?
From my perspective, where you should start is really think about what you're trying to do, what you expect to accomplish, what do you need to accomplish. Don't worry about whether it's an ML or AI problem to begin with. Just really try to document in detail what it is you are trying to accomplish.
I think that is absolutely step one. And step two, then following from that, is do I have the data that I would need to start working on that problem? Because as soon as you have that data and you start collecting it and even just counting what's in there, number of events, defining what's normal, you start to actually have actionable information even before you've brought machine learning into it. So,
are there resources that are available to help with these sorts of things?
What your problem is and what data you need, that's very institution independent or dependent. But there are lots of kind of off-the-shelf machine learning tools available, and a lot of them are much better and much easier than trying to build everything yourself. And so, yes, absolutely. Once you know your problem, once you have your data, use the off-the-shelf tools to get up and running.
Go ahead.
So I wanted to back up a little bit about the data. One of the things that, as you're evaluating the data you have, a good rule of thumb for machine learning right now is if your people can't find the answer in the data, the machine definitely isn't going to, which can give you some insight into what other data you may need to put into, how you may need to combine it, or where else you may need to look, or even if it's a good topic to begin with.
But what if I need a panacea because everything is broken and I don't have the people that can fix it?
There still are no silver bullets.
Well, looking ahead then, where are we headed with this work?
So we've been doing a lot of work on trying to define AI engineering. There's a paper out right now, the 11 fundamental practices. That's not the title of the paper, but basically there's starting points about how do you actually start to build your system once you have done some of your preliminary work. What else are we working on?
I've got 2 research projects that are really working on how we build and sustain the full ML system. So one of the things that happens right now is that you have a machine learning scientist who they build a model and it's great, and then they have to hand it off to a developer, and the developer doesn't know anything about machine learning. And so we talked about data drift and how data changes over time. And so you get to operations and you need to go back and check and see if it's time to update, but you can't check and see if your model's still good because the developer didn't know to put the right hooks in to make those checks. And so that, how do we streamline that communication from the ML developer through dev all the way to operations and make sure that everybody has the information that they need so that nobody leaves the hooks out, right. And formalizing that communication. That's one of the projects that I'm looking at. And then there's another one that, so now you have somebody on the other end who's gotten a report out of the ML system, and now they have to make a decision based on the system's recommendation. How do we present that information to them so that they actually interpret it correctly? That is non-trivial. Humans don't reason well with uncertainty. There's tons of psych research that shows that. So how do we build this whole system to function well?
Specifically on the cybersecurity side, we are looking into trying to figure out how do you actually incorporate context into not just ML, but systems in general related to cybersecurity. Obviously, it's a very big part of what you need for an ML system, but it is also needed in general. A lot of the analytics don't currently work. They're anomaly detection, so you get a lot of stuff that has nothing to do with security. How do you actually incorporate your policies into your analytics or into your analytic processes and workflows?
So it sounds like, in general, we have the questions that people should ask, but we don't have all of the answers fully laid out yet.
I think that's a good way of summarizing it.
Yes.
I know that we're also, with the vulnerability management side, thinking hard about how the AI community will manage, respond to, coordinate, and fix flaws in ML-related software. And so as with any other piece of software, your vulnerability management is going to be a key part of your resiliency for your ML tools as well. So in some sense, nothing new there. In some sense, we have a whole new community of people who are building software who need to be brought into the
Right. So your average data scientist doesn't know anything about building good software and architectures and that sort of thing, and which kind of goes back to that pipeline problem.
Yep. We're going to bring several communities together here, and I think that's one of the things that we're good at with the SEI. I mean, software engineering, that is the thing. Thank you so much for joining us today. As we mentioned, Angela, April, and myself, along with Josh Fallon, Lee Metcalf, and Ed Stoner, have published a technical report on this topic. Go to sei.cmu.edu and type machine learning cybersecurity into the search box, and it'll definitely come up for you straight away. We'll also include links to all these resources in the podcast and in the transcript. So thanks for joining us, and take care.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.